This week, Cambridge consultants are exhibiting at European Utility Week, Europe's largest gathering of water and energy producers, suppliers, distributors and technology providers. This year, the big questions being asked of the sector are: how can we make the utility grids more resilient to future imbalances in supply and demand? How can we enable consumers to take greater control over their utility usage? And how does solving the first and second problem completely transform the way that we trade utilities? Additional to the usual suspects of smart metering and digitalisation, this year we've seen a significant increase in the presence of artificial intelligence and how artificial intelligence can be used to solve these problems. Let's go look at some examples. So here we are at GridHound, who want to help electricity grid operators optimise the amount of distribution capacity and sensing infrastructure they install, therefore reducing their overall system costs. Now, to do this, they use an artificial neural network, and they train it using a combination of the architecture of the grid, the known physics about the system, and a synthesized data set. Now, what they do with this initial model is to identify exactly where in the network they can install the minimum number of sensors in order to get the desired level of accuracy of the model. So once the operators have installed the sensors, and once they've obtained real data sets, they can update the original model, making a more accurate model which operators can then confidently use in order to predict the need for additional capacity. So ultimately, human beings want to live and work in comfortable conditions at the lowest possible cost. And what Enerbrain are doing are enabling the operators of large buildings to achieve this using a combination of wireless sensors, several machine learning and decision-making algorithms, and a wireless HVAC control unit. Now, they train their algorithms using a combination of weather data, historical energy demand, data obtained from their own wireless sensor nodes, and even the schedule of the building itself. So imagine you live in a home with a solar array on the roof, a battery on the wall, and an electric vehicle in your driveway. You have the ability to buy and sell electricity from the grid as you choose. Now, ideally, you want to buy electricity when demand is low and electricity is cheapest, and you want to sell electricity back to the grid when demand is high and it is the most expensive. However, predicting your own consumption, your own generating capacity, and the demand on the grid is non-trivial. Now, what FSite are proposing is using a combination of regression, classification and decision-making algorithms to predict demand on the grid and predict your own consumption, and then autonomously trade electricity on your behalf to optimize your returns and minimize your spend. Now, what I find especially interesting about this is if you apply the concept at grid level, you can imagine a world where the consumer is able to buy electricity directly from the generator, which is a vastly different business model to what we have today. So we've seen some examples of how artificial intelligence is trying to solve the utility sector's problems of today and tomorrow. If you're also interested in how artificial intelligence can be applied in this sector, please don't hesitate to come visit us on stand BN38, where we are showing how artificial intelligence can be applied to water usage disaggregation.